Hello and welcome to Trig Function Graphs Part 1. What we're going to look at is specifically the sine function and the cosine function and the graphs of these things. And we're going to look at certain characteristics of these graphs. The first characteristic I'm going to talk about is you'll notice how these graphs, they just kind of lope along here. These are what we call sinusoidal graphs. Sinusoidal. Okay, they just kind of go rolling along. Sinusoidal graphs or sinusoidal functions, that's what these are. And they're also what we call periodic, which means that they repeat over certain intervals. So these are also referred to as periodic functions. Now, that brings up one of our first characteristics, what we call the period. And the period of this thing is, well, from one point to the point when the cycle ends, and then it starts to repeat. So, you could start here, for example, and say, well, let's start here, and say all the way to here, and this is where it seems the cycle then repeats. Okay, this distance is called the period. Okay. Now you don't have to start here and end here. You could look at a maximum and say, okay, from here, suppose I did this, said here all the way to the next kind of maximum, and that's again where the cycle starts to repeat. You'll notice you get the same distance. Okay, the period is this distance. All right, so that's one of the characteristics, is this distance of how big the cycle is. The other thing is to look at how big these oscillations are, how big above and how big below. And what we do is we kind of split the difference here. If you put like a line down the middle, just like this, okay, sort of a median line, we're talking about this distance here. That's how big the oscillation is. And this distance here it should be exactly the same, right, as this one. The size of this oscillation is referred to as, let's see if I'll just write it here. It's referred to as the amplitude. Okay, and amplitude is a distance. It's how big the size of the oscillation is from this median line. So it's always considered to be positive. Okay. All right, those are the main characteristics that I'm going to be looking at this morning here. And let's have a look at amplitude specifically if we saw it in a function. So I'm going to clear off the screen here and tell you where the number for the amplitude shows up. Well, let's start off. See if my grid shows up. Oh, perfect. There it is. If we were to graph your normal, and we'll look at sine here just to keep it simple. Normally sine goes up 1 and down 1. And then there are those key points at pi by 2, pi, 1.5 pi's, and 2 pi's. And this is what your normal sine function looks like. So I'm just going to draw it in here so it kind of gives us something to refer to. So I'm just going to do a little dotted version here of the sine graph. So there it is. Okay, of course it keeps going, right? All right, so there's kind of what the sine graph looks like. Now, suppose I wanted to change the vertical distances or the amplitude. I wanted this thing to oscillate higher and lower. Really what I want to do is take my function, and if I was going to work with this implicitly, if I wanted to say go up to a 2 and down to say a -2, do something like that. Okay, what I want to do is leave everything else intact, but take vertical distances and stretch them up to there. Take vertical distances and stretch it down to there, so that my graph starts to look like this. Okay. It's really hard to draw this on this tablet. That's not good either. Let's see, maybe I can just sort of do it in stages. There we go. That was the best one yet. Okay. Something like this. Uh-oh. Okay. Stages. That's the key. All right. So something like this. So this is what I'm after. Now, how can I do that? Well, what we saw with transformations in the past was you would put the reciprocal of that in front of this y. Okay. Now, why the y? Because we're changing or stretching it vertically. We want to stretch the y distances, not the x distances. We're trying to stretch the y distances. So we put a 1/2 in front of the y. And that would do it. But typically, these things are not written implicitly. So the way it's sort of conventionally written is that they multiply both sides by 2, and they write it like this. So kind of as a rule, the amplitude is the number in front of the sine or the cosine function. Okay? This number, whatever it is your amplitude. Okay? But where it does come from is this same implicit transformation that we've seen in the past. It's just the convention tends to be they like to put everything on the right side and write it all explicitly. So, how does that help us if we're looking at a particular example? All right, well, we've already done one example here. We just graphed y equals 2 times sine x. Why don't we do a cosine example, and we'll do a different number in front. So this time we're going to graph y equals negative, let's see here, let's make this negative 3 cosine x. All right, so let's get our grid up here. And there it is. So I know that I got my key points at 0, pi by 2, pi, 1.5 pi's, or 3 pi by 2, and then 2 pi. Those are my key points. And I can see here that there's a change in the amplitude, and they've also thrown the negative in there. Now, if you prefer, there's nothing wrong with changing it from this explicit form to the implicit form and doing this. Negative 1/3 times y equals cosine x, and then saying, hey, what changes am I doing to the y's? Oh, I'm multiplying by negative 3. Remember, it's the reciprocal of the number in front. So really what you want to do is take your original y values and multiply them by negative 3. Now, to help make this easier, I'm going to draw in the original cosine graph. So I'm just going to lightly draw it in. So it looks something like this. Oops. I should have made some. All right. Let's fix that up, that one. Okay, so we want to go to here. So there we go. All right, and then back up to our maximum of 1. Okay, that's the original. What we now want to do is take all the y values of these points and multiply them by negative 3. Well, the original y value at this point was 1. Now I've got to multiply it by negative 3, so it's going to be down here. The y value of this point is 0. It's not going to change. The y value of this point, the original, was negative 1. When I multiply it by negative 3, it's now up at positive 3. Okay, then this point, y value of 0, stays as 0. And then the last point is 1 again, so we're going to multiply that by negative 3, and we're back down to negative 3. So what I've done, effectively I've taken the old points. I just didn't want to write it all out. The old point was like 0, 1. And then the new version is what I've graphed. And the x hasn't changed, but all of these y numbers I've multiplied by negative 3. So that's where all these new points are coming from. So now I got to try to make these points look like a cosine graph. Okay. All right. Hey, I'm doing okay. I think the key is to stop, do it in sections. All right, there it is. Okay, not even half bad. Okay, there it is. And you notice it got flipped because this was negative. But if someone said, hey, what's the amplitude? The amplitude is still positive 3. The distance that we're oscillating is 3 up and 3 down from the line, the median line there. Okay, I think that's where I'm going to stop with the sinusoidal functions for now. We'll catch you later.